Welcome everyone to SQL Friday. We're kind of celebrating today. It's an even number at least. So SQL Friday number 70, and a returning star is Uwe Ricken here today. Uwe, who I worked with, well, I'm going to say the first pre-con I went to, it was about performance tuning and methods for performance monitoring, and Uwe was doing that pre-con. It was for a SQL Saturday in Gothenburg. So that's the first time I met Uwe, and then I had the pleasure to work in a project with Uwe quite recently actually. But we both left the project, so now we have to meet on events and conferences again. So I'm glad that you're here today, Uwe. Whenever you're ready, you can take over the screen share. And Uwe is going to talk about cross-database queries and security techniques for it. I'm looking forward to it.
Okay, yeah, thank you very much, Magnus. It's really a pleasure for me being again here for SQL Friday. It's always a pleasure to talk to the community, and I see people are coming in now. I give a big welcome to everybody here taking this time on this Friday. I think a few people are maybe in the weekend at that time. They say, oh, come on, it's 12 o'clock. I will go into the weekend. However, a little bit of SQL Server. And this time, it is about security. It's nothing with performance tuning or best setup, anything like this. It's about security. The reason is very simple. Magnus has mentioned it. We were both working in a project together. The last project we did together was quite interesting, and they worked with multiple databases. The reason behind was very simple. They wanted to have a so-called microarchitecture, which means that every single system had its own database. The problem was the distribution of the data. So we had to have different, all the same data, but in different databases. So the developer's idea was, well, let's distribute the data over all databases. And we said, hey, come on, this is not the right way. Why should we do this? And then I was developing the security framework for them. And I said to myself, well, that's so interesting. Let's do a session out of it. And that's what you will see here. So a few words about the session. If you want to play around with this, you can download the scripts. You see this here in the slides and demos. And I'm using the small database, the customer orders database, which is quite small. But to play around with this, you can use this database. The script can be used by yourself, whatever you want. It's quite easy to understand. Forget about the commercials. Only thing is important. If you have questions concerning security or other SQL Server core engine, just drop me an email. I will be happy to answer your question then. This is our agenda. Very short, very simple. Multi-database systems mostly suffer from security. And the reason is very simple. When I talk to developers, I mostly see or hear, well, we give this account sysadmin privilege. I said, what? Yeah, they said, sysadmin. The instance is just only for us and we can do what we want. But the problem is, if you have higher privileged accounts, it could be, especially when you're a sysadmin, that you will not be only in your box, in your instance, but you can break out into the OS. So this is the reason why you should not give sysadmin privileges, but see what techniques you can use to access data in remote databases. So the easiest way is make a login as sysadmin, but this is just only the funny part here, okay? What can be done is, maybe it works great with granting permissions in all databases. Ask your DBAs, they will definitely not confirm to do that. But maybe DB chaining is an option. That could be a cool option to do this. Or what about trustworthy of databases? So if you set the trustworthy option to gain access to different databases. And the last one, which I show, which is the most complicated, when I say complicated here, is why not using certificates? And I will show you all these different techniques, and you could decide by yourself what would be the best approach for you. This is our demo environment, very, very simple, very, very easy. I will have a database called DemoDB, And this database is the database where the code is running in. So we are connecting to the DemoDB, but we want to access data from the customer orders. Because I'm a little bit lazy, I have created synonyms in the demo database. So whenever I access the table dbo.customers from the DemoDB, it is implemented as a synonym and will go straight forward to the customer orders. Okay? Inside the DemoDB, I have a user called Adam. So what is cross-database security? Think about this. Let's say you're living in a department, in an apartment in a big house, and you are the guy who's called Adam. And you see here at the opposite, this is Alice who is waiting for you. And now think that you want to have sugar from Alice. She's living in the apartment customer orders. So what can you do? In real life, you would definitely agree that you cannot go directly into the apartment from Alice and say, come on, I take the sugar by myself out of your cupboard. Definitely not. So these are the things how you can handle this. Solution number one, what you can do is you can grant required permissions in all databases. What does this mean? When we are, as a user Adam, try to access objects from another database, we need to have access to it. We need to gain access to the apartment from Alice. So that means that we need to have a key for this. Let me show you how this will work. First of all, I will set up the framework. That's very easy. I'm recreating my customers database and the database DemoDB, and I have created the account Adam. Here is a login DB owner. He is Adam. You see this? I created them as a login. So that means he has the key to the instance. So whenever I play around with this login, these credentials are used. Good. Grant permissions in source databases. Let's do a trick. I go into my demo database, and now what you can do as a developer, and this is something which is implemented since SQL Server 2005. I had mostly, before I was working with 2005, big problems to test security because I always needed to open a separate connection, connect it with this login credentials, and then test it. That was very time consuming from my opinion. So with SQL 2005, you have the possibility to use the execute as statement. And here I say, please now switch into the role of Adam. So now I am Adam, and I want to try from inside the demo database, access the customers table in the customer orders. But this will definitely fail. If you look to the error message, you will definitely see what happens. Adam tries to get into the customer orders, go to the cupboard, but that was not allowed. So we do not have the select permissions on the object customers in, but look to this. This is a crucial thing, not in the customer orders, but it's a, well, you are not allowed to access the synonym in the demo database. Oh, that's clear because Adam is just only added as a regular user in the database, but we didn't get give any permissions to this. Okay, do this. So now Adam is allowed to access the synonym. We are not talking about the original data. Let's try it again. Go with Adam and say, give me the customer with the ID number 10. Now the error is a little bit different. The server principal, so the login, Adam, is not allowed to go into the apartment customer orders, which is owned by Alice. So we do not have the key to this. We can access our apartment and all the objects inside our apartment. But if they refer to a different database, we definitely need to have access into this database. Okay, let's try this way. I revert, then I go to the database customer orders, and here I create the user Adam. So that does mean that now Adam can go into the database. But you will see this is definitely not enough, because only gaining access to a database does not automatically mean that you can access the data here. By default, you're in the public role, and that's by default mean no privileges. And now the select permission is not referring to the demo database, but now it's referring to the customer orders database. So everybody know what to do. We go back into the customer orders. We grant the select permission for Adam. So, and for the customer orders, the same way. And let's try it again. And you will see now it is working like a charm. And now we can access the data. This is, from my opinion, the easiest way to grant access to remote objects. But here comes the drawback. If you are a developer and not a DBA, you will say, oh, come on, yeah, that's cool. That's what I want. That's quite easy to handle. And that is something what I can understand. But please ask your DBAs what they think about this technique. I have customers, or think about SharePoint. SharePoint, you have 30, 40, 50 databases in it. If you want to access every single database, you need to have a user in every database. You could now say, well, come on, that's easy. Do it with a script. That's true. But what about if you do not have Adam, but you have, let's say, 500 logins in your instance, and they all need to have access to the databases. This is a huge amount of support what the DBAs need to give you. And if there are any privileges missing, there could be a big, big problem to solve this. For example, you say, okay, I just want to give the insert permission to every user. Come on. Then you go through 500 databases and 500 users and grant this grant insert on table. This will be a nightmare, and I definitely can say your DBAs do not like this way of working. But the technique is available. So what we have to do is we have to add the same user to the resource database, and then we need to grant the permissions on the underlying objects. Otherwise, it will not work. I think this is straightforward, easiest way to handle this. If you're not so familiar with security, then try this approach. It's way better than give us a segment privilege. Solution number two. This is a very interesting thing, but it needs a little bit more understanding about security in SQL Server. Database chaining is a technique where, for example, I would favorite this if I don't want to work with trustworthy or with certificates. Think about cross-database ownership chaining like this. It is a security feature that allows users of databases access to other databases beside the one they are currently using. That's the way how it works. But this one, and this is the most important thing, the cross-database is an extension of ownership chaining, and it does exactly the same process, but now over multiple databases. So to understand how cross-database ownership is working, you need to understand the concept of ownership chaining inside your database with objects. Ownership chaining is a security feature in SQL Server, which is there since I'm working with SQL Server. And this gives you the opportunity to access multiple objects by setting permissions on just only one object. Just to want to give you an example, let's say you have tables, but nobody, you don't want the people to allow the access to the tables itself. You will build let's say a business layer in between, and this business layer can be a view, a function, or a stored procedure. But now think about this. The good thing with ownership chaining is you grant the permissions on the objects in the business layer, and you do not need to give dedicated permissions to the underlying objects. Example, stored procedure. Let's say you will have a stored procedure which inserts data into the customers table. Normally, you must grant the insert permission on the table to any user who should insert data into the customers table. But when you do it with a stored procedure, you grant the execute permission only to this stored procedure. But there is one strict requirement, and this is important here. All the objects you are using inside the stored procedure must be owned by the same owner as the stored procedure. So every single object you are using must have the same owner. And I want to demonstrate this to you. Here is the point. Once again, we are in our demo database, and we have in the schema DBO, the synonym dbo.customers. On the other side, we have in the customer orders in the schema DBO, the table DBO customers. Have a look to the owners. So both databases belong to the same owner. And what we will do is we try a select on this synonym, which is owned by the DBO. Then it checks the owner of the schema, the owner of the database, and up to here, we are now in the good position that we can say the synonym belongs to the owner of the schema, and the owner of the schema is the DBO, who is only a representative user object in the database to the true owner of the database, which is here the SA account. Then we see that the synonym must have access to another database. We now go over to the database and we check first the owner of the databases. So in this case, the demo database owner is exactly the same as it is from the customer orders. Then we go down to the schema and we say, who is the owner of the schema? Is it the DBO? If yes, we can say, well, then the owner is the SA. And then we go down to the table itself. Let's see how it works in reality. So again, just only for checking, I execute this, Adam, and I try to do a select. You see, it doesn't work. We are not able to access the database customer orders. We revert this. So now I want to check who is the owner of the database customer orders and the demo DB. And you see, for both databases, we have exactly the same owners here. Then we look into the database. Who is the representative of the owner of the database inside the database? And you can see here that internally the user DBO represents this database owner. So we can say the SA is the owner of the database. And now there is a little bit complicated query. It looks complicated, but that's very simple. What I want to show you here is the hierarchy of security. This is a union where I go check for the schema, check for the objects, check for the synonyms, and for the procedures. And this is a long query, but the only result I get here is all the objects which I'm referring to, and to see who is the owner of the objects. Let's go first to the database. You see the customer orders database. The owner is the SA account, which gets represented by the DBO in the database. So you see here that the schema is owned by DBO. We can say the schema is owned by the SA, or the schema is owned by the owner of the database. And then we have here the table. And what you can see here is that the table does not have an owner. And this looks a little bit weird because especially when you're looking into the online help, you will see there is a statement say every object requires an owner. Every object. So the table normally must have an owner too. And believe it or not, it has. The owner of the object, if it does not have a dedicated object owner, is mentioned as when an object does not have an owner. The next level in this part here, the schema owner is the owner of this object. So what we can say is the table customers, also it does not have its own owner. The owner of the customers is the DBO, and this one is the SA. So this is the owning chain, owner's chain. Let's go to the demo database. And here, very simple, very easy. Here is my demo database. This is DSA. And we go again down the level. The schema is the DBO. And here you see I have stored procedures. I have synonyms. They don't have object owners. So we can say that all these objects, because they are in the same schema here in the DBO schema, belong to the DBO. So we have a perfect chaining here. Now, whatever we access, we can say whether all objects belong to the same owner in the SA, which is represented in the database by the DBO. So this is what we know. And now see what I'm doing. I now set the option for allowing access outside of a database by chaining technology, by security chaining. We need to activate this for the database. I do this here. I allow this for the demo database and for the customer orders. So both databases are required to open this security feature. And now we check this. Yeah, both are opened. And now let's try to execute this. I start with Adam and say, yeah, give me the customer with the ID number 10. But look to this. The server principal Adam is not allowed to access the database customer orders. And this is clear. Also, both databases belong to the same owner. It does not mean that a user which is in the demo database can directly go into the customer orders. Think about this from real life. Let's say you own 2 apartments. One you have rented to me and one you have rented to Magnus. To be honest, I would say Magnus would not be happy if I could go straight forward into his apartment. Also, both apartments belong to the same owner. So that requires that Adam needs to have access to the database. So I go into the customer orders. Here I create the user Adam. The big difference, what you see here is I did not give explicit permissions to access the customer's table. I just only created the user, which means that now Adam can go into the database. Execute as login, and I say, please give me the record with the ID number 10, and you see it's working. And the reason it is working, that now SQL Server checks the owners of the object and is building a chain from this and say, well, the synonym owns to the DBO, the database both have the same owners, and the object in the target database is also the DBO, and now it's allowed to access it. So DB chaining is, from my opinion, a way better opportunity to gain access to the databases than giving permissions in the database. But this requires from you as a developer that you always keep in mind who is the owner of the object. If this breaks, no chance. Let me show you what I mean. Now I sell my apartment customer owners to a different one. So now the apartment does not belong to the SA, but to a user login called DB owner. When Adam will now want to access the data, it doesn't work because now the owner chain is broken. Yeah, we go from the demo, say SA, to the customer order, say, oh, sorry, that's a different user, a different login. We have two different owners. Sorry, I need to stop here. So DB chaining requires that every single time we have the same owners of the databases. In the moment we change both databases or all involved databases and give them the same owner, that will work again. So it is not required to have the SA as an account, but the important thing is that they both have the same owner. And now it is working again. I think this is a pretty cool, it's a great feature. I love this feature. It makes it, let's say, easier to access remote databases. But it's not the best way to do this. And the question is, well, why? No, think about this. You have seen that we have to add, again, the users to all remote databases. And we are now again in, I would say, nearby the same problem as we were before, because we needed to create the users. Okay, you would say, but we don't need to grant permissions on the object. That is absolutely clear. But think about this. I know it as a long working DBA for a big bank here in Frankfurt. When you as a sysadmin restore a database, who is the owner of the database? The owner of the database is me. And I promise I forgot it so often. When I restore the database, let's say in a DR environment or anywhere, the owner is me. And I cannot change the owner as long as the database is in a restoring mode. What about lock shipping? So when you create a lock shipping environment, that means that we automatically apply locks in the DR side. The first time the restore starts, it is the owner of the restored database is the owner of the execution process. And if it's not the SA, excuse me, then it might be that it's not working. High availability. I think that if you are working with high availability, with availability groups, what about the creation of the database in the secondary? The owner of the database will be you as a sysadmin, but not the SA, and you can't change it. As long as the databases are in restoring mode, you cannot change it. So DB chaining, I would say, is a good approach, but it's not the perfect one. Okay, so I close this. It's way better than granting permissions directly on the database. So the cross-database ownership chaining will work when we have the same account in the remote database. The good thing here is we do not need any more permissions, just only add the account and that's it. And if you're working with, by the way, with Windows groups, which I prefer, then it's very easy. Then we grant required permissions in all databases. The pro is the separation of data and access objects. The users do not need permissions on the remote objects, but the problem is that the login must have access to the remote databases. And it will not work with different database owners. So whenever you are accessing objects with different owners, it does not work. All objects must have the same owner here. So now I showed you two different techniques. The third one is one where I would say, how do I say? I would say yes, it is a good solution, but it is a dangerous solution. And by the way, there is one database in all of your databases has set this option to on, and this is the MSDB database. That is one of the reasons why you never ever in your lifetime, or as long as you want to work as a DBA, you should never ever grant someone access to the MSDB database as a DB owner. I will show you later on why, because that is a high risk. The database option trustworthy. This is a database property where we can indicate whether the instance of SQL Server trusts the database and the content within it. It sounds harmless, but it isn't. By default, this setting is off, but it can be set to on by using the alter database statement. That is one point. What is quite interesting and what hopefully shows you that this is not just only an option, that there is a risk behind. The trustworthy option cannot be set with the GUI. So that means that you cannot do this setting by right-click on the database, go into the properties, go into the options and change it. Not possible. You can only do it by alter database statement. And to set this option, you must be a member of sysadmin. So the DBO or the DB owner is not cannot do this. It can be highly dangerous if the database owner has too much privileges. Please keep always this fourth bullet point in mind. It can be highly dangerous if the database owner has too much privileges. And again, please don't use this feature as a common approach for multi-database access. A user with the membership in DB owner database role can hijack your SQL Server. Yeah. Very dangerous. So let's go and look how this will work. I go again into my demo database. I execute as Adam. And when you want to check the security, the permissions of an owner, of a user, you have two system views, system DMVs. The user token gives you an output about the security context in the database, while the login token shows you your privileges outside of your database on a server level. So here I go with this user token. Look to this. You can see that now, because I'm executing as owner, I'm Adam, and the only permissions I have are the permissions of the public role, because everybody is automatically member of the public role. But you see here that I'm acting as the user Adam. Outside of my database, I am on the instance level, I'm Adam. I'm a SQL login, and I'm only member of the public group on the login level. This is the very interesting thing here to know. Now, I alter my database, set trustworthy on. Again, I execute as Adam. So now I'm Adam, and look to the user token, and suddenly, look to this. Here you see that I'm not only Adam, but due to the fact that we have the trustworthy on, we can execute, or we have the permissions of the DBO which is member of the DB owner. And if I look into the login token, here, look to this, SA. That does not mean that Adam now is an SA. Oh gosh, no. But Adam can act outside of the database only when he acts as a DBO, DB owner. He must be member of the DB owner role. Because when Adam is working inside the database only with his account, you know, he's not a DB owner. That means that Adam is not able to impersonate the DBO. Adam is not in the position to say, well, I'm Adam, but now I want to execute as the user DBO. This can only be done, this so-called impersonation can only be done when you are a member of the DB owner role. Adam is not. So revert. Now I try. So the trustworthy needs to be set. Let's check this. I did this. And maybe now it's working. Execute as Adam. But no. So in the first glance, it looks like that the trustworthy is not working very well. But it is. The trustworthy option does not mean that you are now actually going through the whole instance as an SA. It does only mean that the SQL server will trust everything what's coming outside. But we are not working as the DBO, but we are working as Adam here. Let's go revert this. The key point to work with the trustworthy option is that you access remote objects, not by accessing them directly, but by using a business layer. Look to this here. This is a store procedure where I hand over the ID. And the only thing what I'm doing is I show the login token, the user token, and then I access the data. I grant execute on this store procedure to Adam. And let's see what Adam can do. Execute as Adam. Adam is just only a normal user. And when Adam is now executing this, shit, it does not work. The reason is here very simple. This is my database principal ID. And this here, this is the owner of the database, but Adam is accessing the object with these permissions here. And here again, outside on the SQL Server, I'm only in this role. Yeah, but SQL Server trusts the database. That means, okay, if Adam would be the DBO or member of the DB owner, then we could go outside. How can we do this with store procedures? And I know lots of you know this technique. Just revert this. And Magnus remembers this because we were in a project together. Look to this. With execute as owner, it is now a little bit, just only a little bit more complicated. What does this execute as owner mean? When I talk to developers, sometimes in developer workshops, I quite often hear, well, with owner, it is meant that is the owner of the database. No. The execute as owner does mean the owner of this procedure. I am the DBO here, and now it gets dangerous here. I am the DBO, and the DBO is when I create this store procedure as a DBO, I am now in the role of the database owner. Let's see how it works. I say execute as owner, I add this, and let's see what Adam can do. Go. Now I'm Adam, Adam is now running the store procedure in its own context, but now it's working. Please remember, Adam has not been added as a user to the customer orders. So there is just only one explanation why this could work. We are now inside our database because we said execute as owner, and it does mean the owner of the store procedure. Who is the owner of the store procedure? DBO. Who is the DBO of the database? Well, sorry guys, this is the SA. Sysadmin. Oops. Now I'm working outside of my database in a sysadmin role. And the sysadmin can now access every object in the instance. So we do not have any more restrictions to the customer orders. We can read the data from the customer orders, not because we are Adam and we are looking very perfect and shiny. No, the real one, the real guy who is showing or is accessing the data from the customer orders is not Adam. It is the SA. The SA is going into the database and running the select, and this is allowed to the SA. And I can prove this by evidence. Revert. Now I change the owner of the database so that it is not the SA anymore. And this is a very, very low privileged account. He's only a member of the public role. And now look to this. Execute as owner. We run this again. Oops. And you see exactly what happens. Sorry. The owner of the database cannot go into the customer orders. Why does this happen? Well, we are now accessing the object with the DBO, but who is the DBO? The DBO is this one. And this account does not have any privileges on the SQL Server. So we cannot access this. How can we achieve this to let it work? Because one of the biggest favorites I see here is that I don't have to give Adam permissions to the customer orders database. So the only thing what I need to make sure is that the databases I want to access from inside my code database is that all the databases must have the same owner. I changed to this. And see what happens. So now the database owner of the demo DB is the DB owner, and of the customer orders is the DB owner. But that is okay so far because two same owners, and see how it works. Yeah. So I am now executing as Adam, but Adam now is accessing it because of the execute as owner. Is now accessing this object in the role of a DBO, which is the DB owner login. And this login has access to customer orders, and that's the reason why we can access the data. So here, in this scenario, I would really appreciate to work with Trustworthy. And let me explain shortly, because before we come to the last way to do this. The reason why we did this, Magnus and me, when we were working in this project, is very simple. The problem was that our development was with SQL Server data tools against a managed instance. And the problem was that we could not deploy certificates based on a binary value. That was not foreseen in this in the SQL Server data tools. So we were thinking, oh gosh, what will we do? In a managed instance, we have one big problem. We could not easily do a backup of a certificate and restore it in a different database. So, and then we came to conclusion that it would be best to use this trustworthy option. Also, I always have some trouble with my stomach when I activate this. To be honest, I can't sleep well as long as my database owners are less privileged logins. And then we were absolutely fine, and this worked very, very well for us. Remove this, reset everything, and set the store procedure back to its original code. So as this execute as owner is one big thing what you have to add to a function or a store procedure. So far, everything looks good, and we're going to go now to the next thing. The trick was this execute as. Here it is. In short, I don't want to repeat everything. You can execute a store procedure as caller, as self, which is the default, or as owner. And this is the owner of the object, not the owner of the database. Always keep this in mind. Last solution, and I'm so happy that we perfectly fit in this 1 hour, is, and this is my preferred one, work with signed procedures. A signed procedure does mean that we create a certificate inside our database. Then we sign our store procedures with this certificate. And then the good thing is, what we can do is we have to create the same certificate in all other databases. We create a user from this certificate and grant this user the required permissions. Also, my favorite is the work with procedure with certificates. You have to keep in mind that certificate management, or that experience with certificate management, is required. And think about another point, especially when you're a DBA. If you have signed modules, what about availability groups? Yeah, your certificate is protected by a database master key. So when you, as a developer, create this technology, then your DBAs must know the database master key password, or they cannot run automatic seeding to deploy the availability group database, because it requires the password, the database master key. Otherwise, it won't work. So how does this work? The signed module is very, from my point of view, it's very easy. We have our user again in the demo DB. We want to get access to the store procedure, and this one is signed with a certificate. In that moment, when we sign an object with a certificate, the identity gets switched. So that means that we then can execute, let's say, in the name of the certificate, or this one is that the certificate, that all the privileges what a certificate has can be used inside the store procedure. What can we do now? A certificate is identified by its thumbprint. So that means if you have one certificate in the demo database, you must have exactly the same certificate in the database where you want to gain access to. But the good thing is, it is incredibly easy to do this. Let's go and play around with this. You will see there is no rocket science here. That's quite easy. That's straightforward. So before I start this, because I had the situation in one of the demos that didn't work well, I really make sure that Trustworthy is definitely set off. And here is my store procedure in the demo database, and I grant access to this stored procedure to Adam. So how do certificates work? You need to understand the security hierarchy, and I want to explain it in short words. First thing, whenever you install SQL Server, you get a so-called service master key. This service master key that is protected by SQL Server itself. No chance to do anything with this. The service master key will protect the database master keys. You see this here, and before you start with the certificate, you have to create this service master, this database master key. It's the same as when you're working with column encryption, all this stuff. So what I'm doing now is, in my demo database, I now create the database master key. And in the next step, this is just only to make sure that there is not any certificate here in my database. And now we come to a point where you normally would say, this is the way I create certificates. You see here that I can say, well, create a certificate called my app cert authorization with the owner with subject, blah, 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 blah. But how can you normally transport this certificate to the second database? What you normally would do is you do a backup of this certificate and you restore this certificate afterwards in the remote database. This is the typical way to do this. The problem was in a managed instance, you cannot do this. No way, because then you need to do a backup on a blob storage. Or then you need to restore it. But then the managed instance need access to this blob storage. But what can you do is when you create your certificate, you can read the public and the private information out of this certificate by using the third encoded and the third private key function. And this will give you the binary abstraction of the certificate. And that does mean that it looks like this. And you see here, this is the certificate as a binary value. And look how long it is. No one can crack this. And here is the private key, also as binary. One big problem with this is if you're doing SQL Server development with SQL Server data tools, this will not work. Unfortunately, we tested it and we were driving nuts because we said, what a beep. Yeah. So, okay, now I create my certificate based on these binary values. Done. That's it. So now my certificate is in the demo database. And the only thing what I have to do then is to work with this certificate is that I now add a signature to my store procedure and it gets signed by this certificate. That's it. Let's check it. We execute as Adam and it won't work here because Adam cannot go into the customer orders. The certificate is just only in the demo database, but look to this. Here you see, this is Adam, and this is the certificate. So this is locally, but here, this is the login side. We do not have access to it. So to the SQL Server, we are acting as Adam. Yeah. So what we have to do is, and this is why I love to work with these binary values here. I go into my customer orders. I create my own master key in the customer orders. Then I create exactly the same certificate. It must be the same certificate. It must be the same. Here. But now we come to the last point. You cannot grant permissions to certificates. That won't work. You cannot say grant select for certificate. You have to go a little walk around this problem. You create a user. I call this user data reader. Okay. So here I create a user called data reader based on the certificate I have created before. So now I go into my demo database, execute as Adam, but you will see, oops, it doesn't. This is so weird. No, it's I'm so sorry. This shouldn't work. The key point here is that this user data reader does not have any permissions, and this is what happened once. This is once a while that it suddenly works, and I don't know why. It might be that there is one option open. The key point is normally this shouldn't work here, yeah, because the user does not have permissions. What we have to do is we have to give this user who is in the background a certificate. We must give this one the permissions to act with the objects. So, and now Adam can properly access the data. The good thing here is we do not have to run any administrative tasks to add the users to the database. The only thing what has to be done is that you add the certificates and create a user based on the certificate. So what is required for you, what you need to take into consideration if you work with this? Make sure that you understand certificates and that how to manage the certificates. And the second one is that you understand that you cannot grant permissions to a certificate itself, but there is a manual step that you create a user inside the database, which is based on the certificate, and you grant these users the permissions. And the very last point, what you always have to keep in mind is, as a developer, whenever you change, you alter the stored procedure, you always have to sign it again. Yeah, you always have to add the signature again. Otherwise, when it gets replaced, the signature or the protection of the signature is gone. So that's how it works. And yeah, I hope this is this is all about security, cross-database security, and I hope you liked what I have demonstrated so far. Thank you very much.
I did. Thanks, Uwe.
You're welcome.
I had Erland Sommarskog, I think you know him. He was on SQL Friday to talk about how he handled certificates, and he has written a couple of stored procedures that can automatically create the certificates and sign the procedures for you. But he's not using one certificate for all procedures, but rather one certificate per procedure, and that's the reason why he needed to kind of automate the process. So I think that's an interesting thing to have a look at as well. So.
Yeah.
Do we have any questions from anyone? I don't see any questions in the chat,
yeah.
So I think that means what you did was clear. But if anyone has any questions, then please just, now that the presentation is over, you can just unmute and ask if you want to.
Security is easy.
I mean, how hard can it be?
Okay, what I think then, Mikael is writing, yeah.
Yeah, I mean, in the meantime, while he's typing, splendid presentation. Okay, and it's frustrating sometimes to think about security, because you often come to clients and you look at how do they implement security. Well, they're using the sysadmin scheme. Well, let's just make all the service accounts use sysadmin. Perfect.
Yeah, I see it very often, and what I very, very often see is so I would say 90% of the applications, vendor-driven applications, they want to have, first of all, DB owner permissions, which is basically, I would say, not required when you see the workloads. Yeah. And what I see very often too is, and this is quite annoying, is that they want to be sysadmin because they are using, for example, XP command shell very heavily. Where I say, hey guys, you know what you're doing there. Yeah? They can take over your computer. Yeah? And the third thing what I see, and that makes me really nervous, is the vendors. I would say in 30 to 40% of the customers where I am, they have unlimited access, day and night, uncontrolled, not monitored access to the production server. So they go from outside and they can access it whenever they want. Yeah, Stefan, alles Gute. So, so this is sometimes a little bit frustrating. And then people are complaining about stolen data or something like this. It's what it is.
Yeah, it is. And I mean, it's frustrating in the way that when I bring up that maybe, I mean, when I come somewhere, I'm a contractor or a consultant, so I can't really just tell them you should do this. I have to convince them to want to do something or want to do it for them. And it's not until a customer is hit by a security breach that they realize that maybe we should have listened to what this person said. So even when I show that, you know, that the setup you have, this can happen, and I can show a demo that it might happen, they're still not going to do much about it because it will slow down the development. The developers have to rethink the way they do things, so they won't have any functional requirements for a sprint or two.
Yeah, I know this. I can understand this, but to be honest, this is not the right way to do this. The project we did, that was correct. But we were 4 high-level experts.
Yeah, exactly. And that's also a thing. I mean, you really need people who know what they're doing when you develop new things. So
yeah, that's the way how it's working.
Yeah. Well, no questions, but some comments.
Questions here.
So I agree with them. Splendid presentation, as always.
Thank you very much, sir.
I know that when you're doing demos, they work, and that's.
Unfortunately, the last one not, and I had the same situation. I think it was in Belgium, and I said, "See, it's not working," and bang, they saw it. And I said, "Gosh, what's going on here?" And now I had exactly the same situation. I need to figure out what is the problem here. I don't know. Sorry.
Yeah, but it's an exception. I know that you do prepare your demos, and we have talked about this. You have an opinion about a presenter.
Yeah.
The PowerPoint doesn't have to be great, but the demos have to work. So.
Demos must work. Yeah. Unfortunately not, but I hope your audience will forgive me. And,
I think you will. I will, at least.
Okay. Thank you very much, guys. Then